Okay, so in this session, I want us to continue our discussion on trigonometry. But then in this session, I want us to look at compound angle formulas, compound angle formulas, eh, compound angle formulas. And then I want us to also look at double angle formulas, double angle, yeah, double angle formulas. Okay. So let's start with the compound angle formula. So um, compound angle formulas. So we have a situation like this. Let's say we have sine of angle A plus angle B. So this situation is what we call a compound angle. Okay. It's basically the sum of the difference of two angles that gives us a compound angle. Okay. Now, if we have sine of A plus B, then the results of this will be sine of A, cos of B, and then plus sine of B, cos of A. Okay. Please note that the proofs for these formulas are beyond the scope of high school mathematics. They are ways to prove these formulas, but then they involve complicated mathematics, which is beyond the scope of high school mathematics. So what I'm going to do in this session, I will basically provide the results of the proofs, okay, which are basically the formulas that we will have to apply when we are doing exam questions and so forth and so forth. Okay, so that is the case. Um, Now, if we have sine of A minus B, then this will produce sine A cos B minus sine B cos of A. Okay, so this is the compound angle. And one cool way to remember this is the fact that number one, if we are dealing with the sine, the sine ratio, the sign does not change. Okay, so as for sine, as for the fact that the sign stays the same. Okay, so this was minus, this is minus also. Okay. Now, if you look at the cost one, you will see that when it comes to the cost, then the signs change. They change. So if we have cost of A plus B, this is equal to cos of A, cos of B, minus sine of A, sine of B. Okay. And then if we have cos of A minus B, then what happens is we will be left with cos of A, cos of B, minus, not minus, it should be plus, sine of A, sine of B. Okay, so what we can see with the cost ratio is the fact that when we are looking at compound angles related to cos, the sign changes. Okay, we started with a positive, but then the other side has a negative, and then here we started with a negative, but then this side has a positive. Okay, and we can see the difference because here we had sine and then cos, but then here we say cos cos, then we say sine sine. Okay, so these are the formulas for our compound angles, and then let's look at the formulas for double angles. Okay, so anything that is double is anything that is multiplied by 2. Okay, um, so double angle formulas for formulas. Okay, now this one is a very simple one as well. Sine of 2a, okay, is equal to 2 sine a times cos a. Okay, so this is the formula for the double angle related to sine. Okay, and then if we have cos of 2a, this will give us cos squared of a minus sine squared of a. Okay, now this is a very interesting one because we established previously, if you will recall, that cos squared of a is actually equal to 1 minus sine squared. Okay, 1 minus sine squared a, and then the same thing can be said about sine squared, that sine squared is basically equal to 1 minus cos squared. Now this means, or this implies, that we can we can obtain two other formulas from this one. Okay, because I can choose to replace cos squared theta with 1 minus sine squared theta, and then I will get a different formula. Okay, let's do that. If I replace this guy with 1 minus sine squared a, um and then minus sine squared a, what happens is that I have minus, so it will be 1 minus 2 sine squared a. I'll end up with 1 minus 2 sine squared a. Okay, so this is another version of this guy. Okay, and then the very same thing can be done if we replace sine squared a with 1 minus cos squared a. Let's do that. We can say that cos squared a, minus 1 minus 1 minus cos squared a. Okay, and then um, we have what? We have cos squared a, and then minus 1. This minus will make this minus to turn into plus, so it will be plus cos squared a. Okay, and then as a result, we see that this and this guy, they are like terms, so we'll end up with 2 cos squared of a minus 1. Okay, so this is the third version of this double angle formula. Okay, so as a result, we conclude that sine 2a is equal to 2 sine a cos a, and then cos of 2a is what? It is equal to cos squared of a minus sine squared of a, and then Another way of representing cos of 2a is saying that it's 1 minus 2 sine squared a. And then another way of representing cos of 2a is saying that it is equal to 2 cos squared of a minus 1. So these are the three representation of cos cos 2a, okay, or the double angle formula for the cos ratio, okay. And we will see when we are doing exam questions that depending on the type of simplification that needs to be done, we will find that replacing cos of 2a, we can replace it with this one, we can replace it with that one, or with that one. But then in different situations, you will find that one is more convenient to substitute. Okay. We will demonstrate more of this when we are tackling exam